friends. In this lecture, we have to study a new chapter from 12th Physics, chapter number 2, Mechanical Properties of Fluids. Myself, Rahul Kotkar, and let we start the chapter Mechanical Properties of Fluids. In introduction, we have to study some previous concepts. What is the matter? Matter is the stuff that makes up universe. What is a stuff? Stuff means the material. The material which is nothing but the particular particles collectively made a matter. Then everything that take space as well as has a mass is called matter. Everyone know the states of matter. There are three states of matter, that is solid, liquid and gas. Now the smallest small particle of the matter is called as atom. Okay, means solid, liquid, gases all are formed by a small particle called atom. The arrangement of these atoms in such a way that solid have a very closely packed. You can see this table. In case of solid, solid have a fixed shape, while liquid and gases have a variable shapes. Always remember the volume of the solid is also fixed, as well as for liquid it is a fixed, but gases have a different volume, or the volume should be variable. Now intermolecular spacing between the molecules or atoms, okay, means two atoms are separated by a distance, that is called the intermolecular spacing. In case of solids it is very closed, okay, so due to that they have a good bonding between the two atoms or molecules, and that's why solid have a closely packed structure. While in case of liquid they have a closed pack, means their molecules are close together but not bounded much more as similar to the solid, means they loosely bound as compared to the solid. In case of gases, they are far apart from each other, means the force of attraction between these atoms or molecules should be a smaller as compared to solid as well as liquid. Okay, so in this manner it is a general thing about the matter. So in case of this, the second topic that we have to study, that is a fluid. What is the fluid? Fluid is the substance that can flow. Okay, everyone know the liquid, gases can flow from one place to the other place. Okay, means liquid and gases are collectively called as fluids. So some important thing that we have to understood about the fluids. Fluid is the substance that deforms continuously under the action of external force. Okay, simple thing. Let's just, if you open the water cock, so what happens, that liquid will starts to flow from that water tap. Okay, means what, the substance deforms continuously under the action of external force, means as you open the tap the force on it get reduced, means pressure will get flow from high region to low region and it will starts to flow. Second, the fluid is the phase of matter which capable to flow, that includes liquids, gases and plasmas. Okay, in case of fluids it's a state of matter as similar to the we studied in the previous slide, that is what solid, liquid and gases are the three phases of matter, but instead of that the fourth stage of matter is called plasma. So liquid, gases and plasma are includable in the fluids. Okay, so you can see here solid. Okay, in case of solid we give the example of ice. In case of liquid, we take an example of water. Okay, and you can see here the atomic structure or the bonding between the atoms. You can see in this following diagram. Okay, here the ice should be having a closely packed structure because it is solid, while liquid having a less bonding, while gases have a more less bonding. And in case of plasma, they should have a much more separatable. Okay, so what is the plasma? So plasma is one of the fourth fundamental states of matter. It consists of gas of ions, free electrons and neutral atoms. Okay, means when a gas get heated, okay, then the plasma will be formed. So you have to just remember here what is the fluid, the substance that can flow, and which fluids we are going to study here in this chapter: liquid as well as gases. Okay, means in this 12th standard we have to study about the liquid and gases. In this chapter we are mostly talking about the liquids. Okay, the shear modulus or modulus of rigidity of the fluid is always 0. What is the shear modulus? So shear modulus is related to the shape of the given matter or given substance. So what I have to explain here, simple, they have a 0 value of shear modulus or modulus of rigidity. Means what? It cannot resist to the shear force which applied on it. Means they do not oppose the external force. Okay, means it's very simple. As your container contains the liquid, say as to water inside it, as you open the one side of the tank, okay, let me consider here, suppose here we have a cubical vessel in which a liquid is fulfilled. So as liquid is taken inside it, if suppose I open the one side of this tank, so what happens, as this tank get open, so the water will flows or liquid will flows outside. Means what? As you apply the force, okay, so the water will be flow outside. Means there is no oppose to the change of shape. Okay, means they get easily deformed. Deform means what? They should change their dimensions easily. Next property, that is a fluid flows under the action of force, that is a pressure gradient. Okay, everyone know the tap of water or water flowing from the pipe. Okay, so as you open that tap, what happens? It should be moves easily outside because the pressure variation is there. Okay, as there is a pressure variation, so water comes out from the tap. Either we can give the other example, air filled inside the cycle tubes or any kind of vehicles. Okay, paste, toothpaste which is coming out from the toothpaste. Okay, molten lava. Okay, molten lava should be the concept that will be arise from the ground. Okay, because of the pressure variation. Okay, in this manner these are the some examples related to the fluids. So in this chapter we are mainly going to study into the two parts, that is the hydrostatics and hydrodynamics. What is the hydrostatics? So the branch of physics which deals with the property of fluid which is at rest is called hydrostatics. Okay, means in short what we can say, the study of fluid at rest is called as hydrostatics. Second, hydrodynamics, the branch of physics which deals with the study of property of fluid in motion. Means when the fluid is in motion, the study of such a fluid is called hydrodynamics. Okay, so these are the two main branches or two main topics that we have to cover in this chapter. Properties of ideal fluids. So first property, it is incompressible. that its density is constant. Okay, if suppose you should take a bottle having a capacity of 1 liter, okay, it is not possible to fill the more water by compressing inside that particular liquid bottle. Okay, means we cannot fill a more water than that of the 1 liter. Means it have a fixed value, or it have a fixed density. Its density remains constant. A liquid filled inside the given container, okay, if suppose we consider that this is the liquid container, inside this container the amount of liquid filled, suppose 1 liter, it is not possible to fill more liquid inside it because it have a less value, constant value of density. Okay, the flow is irrotational, that is no turbulence in the flow. Okay, what is the turbulence flow? So remember here, the flow is irrotational. Okay, means there is no rotations are there. Okay, if you consider that this is the liquid flowing through the pipe. Okay, so the particle of liquids, each particle of liquid molecule should have a different velocity. They can move with a different velocity. So such a flow is called turbulent flow. Okay, and means here there is no turbulence, means what, all are moving with the same velocity. Okay, actually this concept was we have to explain or study in more details in the next chapters. Okay, it is a non-viscous. Okay, viscosity, it is a property of liquid. As you observe the friction in solids, in similar manner there is the friction in between the liquid layers. Okay, if the two layers of the liquid are flowing on the surface, at that time one layer can oppose the motion of the other layer. The motion which is moving, okay, can oppose the motion of the adjacent layer. This property is called viscosity, and here we can say that the ideal fluid is non-viscous, means it doesn't have the viscosity. Then fourth property, its flow is steady. Okay, means it have a laminar flow. What is a laminar flow? Okay, the laminar flow is the flow in which all the particles, okay, just I told like that, all the particles of the liquid are moving with same velocity. Okay, so this property is called as a steady flow or streamline flow or laminar flow. Next, that is the difference between the solids and fluids. So read it carefully. What you observe, solid can be subjected to shear stress. I just explain you what is a shear stress. Okay, simple. If you consider this is the container, or this is a particular object, say as to it is formed due to the layers. Okay, if you apply the force to the uppermost layer, then what happens in case of solid, you observe the structure like this. Means what happens here, there is the change in shape. Okay, just previously I explained that. Okay, the shear stress is subjected to the change in shape of the object. But in case of solid, it should be possible. Means what, solid can be subjected to shear stress. This shows the change in shape. Okay, either by tangential stress or normal stress. But in case of fluid, the ideal fluids can only be subjected to the normal compressive stress called pressure. Means in case of ideal fluids, there is only the normal or compressive stress is there, which we call pressure. Okay, What is the pressure that we have to study in the next point? Solid opposes the shear stress either by developing the restoring force. Okay, means what? While applying the force on the external layer, uppermost layer, topmost layer, so at that time this solid will not change its shape directly or automatically. Okay, it will take a certain time, or it will take a certain internal oppose. Okay, means it opposes to the change of shape. Okay, so in this manner solid opposes the shear stress. But in case of fluids, the real fluids display viscosity and so are capable of being subjected to low level of shear stress. Means in short, they will not oppose for a shear stress. Okay, means if suppose if you take a liquid into a container, say as to suppose it's your a kind of cup. Okay, if you pour it into a big vessel like this, so what happens? They will not oppose to the change of shape. If you pour it in this particular container, so what happens? It will be take the shape of that container easily. Means they will not oppose to the formation of change of shape. Then next one, they require a certain initial stress before deformation. Okay, before deformation in case of solid, they require initial stress. Okay, means for example, if you want to stretch the wire, okay, for forming the deformation, means for changing its length, initially some stress will be required. Okay, means force acting per unit area will be required. But in case of liquid, no initial stress required for deformation. Okay, so this diagram can show you simply the properties which I just explained you. Shear stress, okay, which will be looks like this. You can observe here. Okay, there is the action of force at this place, so it will be changes the shape. Okay, and it will becomes A, B, C dash, D dash. Okay, this is the compressive force. Okay, A figure shows the compressive force while the B figure shows the tensile force. Okay, what is the compressive? Means the force externally acting like this inside the, okay, acting towards the body. And what is the tensile? So this will be acting like this. Means here we can say the stretching of the wire, while here we can say the compressing. So in this manner, this is your compressive stress and this is your tensile stress. Okay, then in case of fluids, okay, at rest, they exert the force on a particular object which is put inside it. Means if suppose you take a container like this, okay, so in this container you can see here, if it contains the liquid at that time, okay, if you put any object inside it, it will exert the force on this walls of that particular object. Okay, so that is a force acting on a small surface. Next, that is your properties of fluids. Okay, we just studied about the properties, that are the properties of ideal fluids. But actually, what are that? They do not oppose deformation, they get permanently deformed. Okay, which is similar to the ideal fluids. What is that? They do not oppose the deformation, means they easily changes their shape. They have ability to flow, means they can flow easily. Okay, they have ability to take the shape of the container. Just I explain you what is that. If you put a liquid into the glass to a dish, what happens? It can change its shape easily. A fluid exhibits this property because it cannot oppose a shear stress when in a static equilibrium. So why the fluid shows such a property because the main reason is there, it cannot oppose a shear stress. It cannot oppose a shear stress at static equilibrium. So fluid shows such a properties. Next topic, okay, which is very important, fluid at rest. So we just studied this definition, the branch of physics which deals with the study of properties of fluids at rest is called hydrostatics. Okay, in short, the study of fluid at rest is called as hydrostatics. So in this case, we have to study the next point, that is a pressure. So what is the pressure? A fluid at rest exerts the force on the surface of contact. The surface may be wall or the bottom of the container of the fluid. Okay, you can see this diagram. What you observe here, just before I will show you some sketch like this. If suppose it will contains a liquid, this vessel contains a liquid, so this liquid can exert the force act on a wall. Okay, means it will exert the force on the wall of the container as well as bottom of the container, as well as it can also exert the force, okay, the object you should kept inside this fluid. Okay, here also the fluid exerts the pressure. So according to that, we define the pressure, the normal force exerted by fluid at rest per unit surface area of contact is called the pressure of the fluid. Okay, remember students, we studied the simple definition. What is that? Force acting per unit area is called as pressure. But here we have to study the pressure in terms of fluids. So for that, the definition just get modified. What is that? The normal force exerted by the fluid at rest per unit surface area of contact is called pressure of fluid. Okay, means that is simply the normal force which exerts on the walls of container or on the bottom of the container per unit area, that is called as a pressure. Okay, and by simple formula, that is P is equals to F divided by A. So here what we can say, thus an object having a small weight can exert the high pressure if its weight acts on a small surface area. Okay, for this thing, remember the statement told you like this: if you act a small weight, okay, on a object, it will shows the high pressure. Okay, here simply for that we just go through this example. What is that example? It contains a force of 10 Newton acting on 1 centimeter square results in a pressure of 10 to the power 5 Newton meter square. Okay, listen, how much the force acting? 10 Newton. How much the area? 1 centimeter square. Okay, means what? The object having small weight can exert the high pressure if its weight acts on a small surface area. Okay, here according to this, the force acting is your 10 Newton and area should be 1 centimeter square. So for that, what is the value of pressure? By calculating it, it is a 10 to the power 5 Newton meter square. You can observe this 10 divided by 1 centimeter square, but centimeter square has to be converted to meter square, and therefore it should be the 10 to the power minus 4. Okay, you have a conversion. 1 centimeter is equal to 100, 1 divided by 100 meter. Okay, therefore what we can say, 1 centimeter square is equals to 1 by 100 square, that is a 10 to the power minus 4 meter square. Okay, so in this manner, this is a simple conversion. Then what we consider here, the same force of 10 Newton. Now force is the same, but now area, while acting on an area of 1 meter square, now we increase the area. So it exerts a pressure of only 10 Newton meter square. Okay, now you can observe here, when the force is same in both cases, area 1 centimeter square and here 1 meter square. Okay, so the pressure acting is 10 to the power 5 Newton meter square, and here pressure acting 10 to the power 10 Newton meter square. Means what? As area increases, okay, simple, as area increases, pressure decreases. Okay, you can observe or you can understood it by using this example also. Okay, it's simple, as force is constant, then as area increases, pressure decreases. Either you can say that area decreases, pressure increases, means vice versa. So this is the pressure. Now 1 Newton weight is about 100 gram mass if G is equals to 10 meter per second square. SI unit of pressure is Newton meter square. So by using simple way, force acting per unit area is what? Pressure. So force is measured in Newton and area is measured in meter square. So in this manner, its SI unit is Newton meter square. Also 1 Newton meter square is equals to 1 pascals and having a symbol PA, that is Pa. Okay, the Pascal is the name of scientist which is given in the memory of scientist Pascal. The dimensions of pressure are given, that is L raised to minus 1, M raised to 1, T raised to minus 2. Okay, force having dimension M raised to 1, L raised to 1, T raised to minus 2. Okay, divided by area. So I just write here L raised to 2. So as 1, okay, L raised to 1 is at the numerator, at the denominator L raised to 2 is there. So therefore 1 minus 2 becomes minus 1, and so it should have a value M raised to 1, L raised to minus 1, T raised to minus 2. Pressure is a scalar quantity. Okay, just remember, pressure is the scalar quantity. What is the reason or why we called pressure is the scalar quantity? Even the force is the vector. So the liquid closed inside this container, liquid present inside this container will exert the force on the wall on bottom of a liquid, okay, which not required any direction or which not depends on the direction. Okay, means what? The pressure acting in this direction is same as that of the pressure acting in this direction, as well as same here also. Means it will not depends upon the direction, and so pressure is the scalar quantity. Other common units for measuring the pressure of a gas are bar and torr. Okay, means for measuring the pressure, bar and torr, this kind of units are also used. 1 bar having a value 10 to the power 5 Newton meter square. And again one more unit and conversion is there, 1 hectopascal is equals to 10 to the power 2 Pascal or 100 Pascal. Okay, these are the simple conversions. Now the question from your book, that is, can you tell why does a knife have a sharp edge and a needle has a sharp tip? Okay, everyone observe that if your knife do not have a sharp edge, then it cannot cut the vegetables or fruits, okay, easily. You should require a much more force. But if you have a sharp edge, then what happens? It can easily cut the vegetables or fruits. So the reason is the needle have a sharp edge which exerts a large pressure on a point of contact for pressing them into the object easily. Okay, means similarly we can say the examples. Before that I have to explain this. Okay, the needle have a very small and sharp edge, as well as uh, knife is also have a sharp edge. Okay, if they have a sharp edge means they have a less area of contact and they can exert the more pressure, as we see previously. As we saw the previously, what is that? The pressure and area are inversely proportional to each other. So small area large pressure, large area small pressure. So in this manner, if the area of the knife or needle has a sharp, okay, so then what we can say, they can exert the large pressure. In similar manner, hammering of nail, other examples, hammering of nails is easy because nail has a sharp point. Sharp edge of nail, scissors, saw, axe produces a large pressure on small area. So this is the reason why they have a sharp edges. Now, pressure due to liquid column. So for that we consider a vessel which is filled with a liquid. Let we calculate the pressure exerted by an imaginary cylinder of cross-sectional area A inside the container. Means what we are going to consider here, inside it we are going to consider the imaginary cylinder. This cylinder considered here, which is the imaginary. Okay, means there is no physically presence of this cylinder. We consider this cylinder inside the liquid container. Okay, so it will have a area of cross section A and height h. So let me consider that rho be the density of the liquid or fluid, h be the height of imaginary cylinder that you observe in the diagram. The liquid column exerts a force F is equals to mg. Okay, this liquid column exerts the force, that is the F is equals to mg. So which is nothing but, okay, this liquid column presence in the cylinder exerts the force in the downward direction, which is called as mg weight. F is equals to mg. Okay, which is its weight on the bottom of the cylinder acts in the downward direction. I just explain you what is that. Downward force equals to weight mg. Therefore, the pressure P exerted by the liquid column on the bottom of cylinder is, okay, how much the pressure exerted here, so that can be given by formula pressure is equals to F divided by A, and F having value m into g. Now, as we know that the mass can be defined as volume multiplied by density. Either the formula for density is equals to mass per unit volume, and according to that what we can say, the mass is defined as density multiplied by volume. So in this case, volume of cylinder is nothing but area multiplied by height, and density is rho. Therefore we have a relation A into h into rho by substituting this value into the mass, we get a relation that is P is equals to A into H into rho into G divided by A. As A get cancelled, we have a relation P is equals to H into rho into G. So thus what we can say here, the pressure does not depends on the area of imaginary cylinder used to derive the expression. Okay, what is the meaning of this one? Means in this case, the pressure due to the liquid column is not depends upon the area, while it depends upon the height h. Okay, it doesn't have area, means it do not depends upon area, but it depends upon the height of the liquid column. Means how much the longer height, the larger is pressure. Now remember, as P is equals to H into rho into G, the pressure exerted by a fluid at rest is independent of shape and size of the container. Okay, whatever it may be the shape of the liquid container, okay, the pressure exerted by the fluid at rest which not depends upon that particular shape, because here we can see the height should be decide the pressure exerted by the liquid column. Then P equals to H into rho into G. It is true for all the liquids as well as for gases. So friends, in this